Hello everyone, my name is Viraj and today we'll be looking at the fourth problem from the CP-31 sheet by TLE Eliminators under the 800 rated questions. Let's go. So I'll be moving on to the CP-31 sheet over here. I can see all my 31 problems and my 800 rated parameter is ticked off, and we have the fourth problem, game with integers. Let's click on this. So this opens up our problem. Let's read. So Vanya and Vova are playing a game. The players are given an integer n, alright. On their turn, the player can add 1 to the current integer or subtract 1. So basically an operation of adding 1 or you subtract 1. Now the players can take turns. Vanya will start. If after Vanya's move, the integer is divisible by 3, then he wins. If 10 moves have passed and Vanya has not won, then Vova wins. Alright. So they are saying write a program that based on that integer n determines who will win if the players play optimally. So this is a very important sentence. Players play optimally. When they write such a sentence, what they mean by this is simply the players want to win. So Vanya will play in such a way that she wants to win, and Vova will also play in such a way that he wants to win. Alright. So that's the whole problem itself, a very short statement. Let us try to generalize the whole thing and understand what are they asking. So they have given you very simple. They have simply given you a single digit, that's n, single number, sorry, that's the number n. And then they have some property related to the divisibility of 3. So what they are saying is, there are two people, this is Vanya, alright, and this is Vova. And they basically are alternating between player of turns. So basically you can say, currently I start with Vanya, then Vova plays, then Vanya plays, then Vova plays, then Vanya plays, then Vova plays, and so on, and this continues. Until somebody wins. Now the winning condition, what's the winning condition? Let's try to understand that. The winning condition is, you are given an operation. This operation looks something like this. Either you change n equals to n minus 1, or you change n equals to n plus 1. These are like the two operations given to you, which you can perform in every turn. So let's go. When you are with Vanya, Vanya might or might not do this change that either he increases the number by 1 or he decreases the number by 1 and so on. And similarly, Vova might do something that he thinks is the most suitable move for himself. Now, what is defined as a suitable move? I know they want to win, and the winning condition is I want to create Vanya, I want to create a situation where when Vanya's move is over, you can say after Vanya has done his move, the integer becomes divisible by 3. So I'll say n mod 3 has actually gone to 0. If this is the case after Vanya has played, after Vanya has played, then I'll say Vanya wins. She's the winner, or sorry, he's the winner actually, and he wins. But if Vanya is not able to do this change in above 10 turns, as in he has 10 turns, but if 10 moves have passed and he has still not won, then automatically I'm going to crown, I'll crown Vova as the winner. Let me rub this. I'll say Vova is the winner. Alright, great. So now we have understood the question. It's basically a simulation in my head. Somebody does something, so on. Goes up to I think 10 turns maximum. If after 10 turns you think, oh no, Vanya did not win, just simply crown Vova as the winner. Else you will crown Vanya as the winner. Alright, so we have understood the problem. Now to determine which player is winning, what we are trying to print is either we print first, because that would mean Vanya wins, or you print second, that would mean Vova wins. So just a, you can say, requirement in the question to print first and second instead of Vanya and Vova. That's not a problem. First we need to understand how do we actually come up to this conclusion. Alright, so now we have understood the problem in a generalized manner. Let's try to understand some test case. Alright, let's see test case number 1. Okay, so very simple, or better we can say some other test case. Let's see test case number, like this test case 5. Alright, so given that n is 5 to you, what can happen is you're standing currently with Vanya and you say Vanya, okay, go ahead, it is your turn. So can Vanya do something like this? Can he change n equals to 5 from 5 plus 1, that's actually 6. Yes, he can. He's going to do one operation, as in one turn max. And now do you think 6 mod 3 is equal to 0? Yes, it is. So can I say that in the very first turn, Vanya will be able to make the number 5 go on to a multiple of 3, as in it will become a number that's mod 30, and Vanya is going to win. Hence, I can say for this test case, the answer turns out to be first. Alright, and then of course there is some ideology behind why the answer is second, but we'll look into that part when we actually determine the whole explanation. Alright, great. So now what we'll do is, we have understood one test case for n equals to 5. Let's try to first look at the input. What are they saying? Input is very basic. They are talking about a single number n. So what we can first formulate in our head is, how much expected time complexity am I allowed to go? So now of course, we'll see over here that time limit per test case is 1 second. So we know the very basics. We know that 1 second has a limit of 10 power 8 elementary operations given to me as the running factor in C++ or generally in this language. So now I can say that if I have 1 second as 10 power 8 operations, and I know that I have been given a total of, you can say 100 test cases over here, correct? So I'll say that if I have been given a total of 100 test cases, then the time required or time allowed per test case for you to run would be 10 power 8 upon, this is going to be 10 power 2. That's actually the total number of test cases, which gives you 10 power 6. That means for each test case, you have 10 power 6 at most elementary operations you can run. So very, very important. Now, why am I using this? Why am I trying to calculate this? Because inside my head, I know now that if I want maximum of 10 power 6 elementary operations to run, I can look at n. N is given in an order of 1000. The max order n can go is in 1000. So now, can I create a solution of O of n cube? No, I cannot. Because O of n cube means O of n cube will go in 10 power 9. And 10 power 9 is far greater than 10 power 6. That's my limit per test case. So can this run? Not at all. This cannot run. That means I need to go lower than this. So my idea chunks out saying, okay, let's go something lower. Maybe n square. Will n square work? Yes, n square will work, because n square tells me that it's 10 power 6, as in you do the square of 1000, that would be 10 power 6, definitely works. Now what about something below than this? Will O of n work? Yes, of course O of n log n also works. Of course, maybe even smaller than this, I know that log n similarly will of course work, and in the best case, what if you create a constant time solution? That also works. So now why I have written down this is, now I have a clearer picture on what is the highest time complexity I can achieve. I have an upper bound. I know whatever solution I create, I cannot go above n square. So I have written down my expected time complexity, which helps me formulate my idea further. Whenever I'll create a solution, whenever I'll think of some approach, I'll always ask myself, before implementing it, is it going above n square? That's my upper limit. If it is going above n square, no, I don't do that. Of course, I can create something below n square, that would be great to go, maybe even constant, best case, but not above n square. So this is a very brief idea I need to keep in my mind before I actually dive into creating some solution for the problem. Alright, so now this is the expected time complexity. Let's now look at the final, as in the explanation of what do we actually observe in this case. Alright, so now let's talk about n. N has a divisibility related to 3. That means what we are ideally talking about is, you have 3 cases. I'll jot them down. So basically I'm saying that either this value, that's n mod 3, either this value n mod 3, either this is equal to 0, either this n value initially only n mod 3 is equal to 1, or the final case is n mod 3 equal to 2. What are the examples? If I say n initially only mod 3 is equal to 0, that means numbers look like, let's say 3, 6, or even it can n go 0 in this case? No, n is starting from 1. So I can say 3, 6, 9, 12, and so on, all the multiples of n. What about this case? What are the examples? If n mod 3 equal to 1, then this can be 1, 4, then I can add 3, this is 7, then this is 10, and so on. Similarly, what about these examples? This can be 2, 5, 8, 11, and so on. These are the examples. So if n is given something like this, of course n mod 3 is 0. If n is given any number like this, 1, 4, so on, then I know n mod 3 is equal to 1. And if n is given any number like this, then n mod 3 is equal to 2. Now, why am I writing this down? Very important. Because I know of course I'm starting somewhere with n, so maybe I can create a logic around n. what is the initial value that helps me get this part? I know that if I have n and I have bifurcated in the three cases, maybe I have some idea. Let's try to understand. Let's take a very simple case. What if you say that n mod 3 was equal to 2? So it's basically any number from this set, 2, 5, 8, 11 and so on up to whatever range n can go maximum. These are these sort of numbers. Now, if you are given these sort of numbers, so I'll be discussing, I'm discussing basically case 3 right now. I'll mark this over here also. So this is the case 1, case 2, and then this is case 3. All right. So now if I am discussing case 3 and I'm saying, okay, the nature of n currently is n mod 3 equal to 2, then what does this mean? Let's take some very simple example. Anything I find the answer, of course, for a number natured n mod 3 equals to 2 is going to be applicable everywhere. So let's say n was, let's say 5. Then what can you do exactly? What is your target? Vanya will start. Vanya will, of course, want to make this number a multiple of 3. It's not currently a multiple of 3 because n mod 3 is equal to 2. I want to convert it to something that looks like n mod 3 equal to 0. So remember, you are standing at 5. What is like the next just number you can get to convert this number to n mod 3? Carefully look over here. You are at 5. If I add 1, will I go in this subset? Will I go in this set of numbers? Will adding 1 to 5 make me go in a set where I have n mod 3 equals to 0? Yes. And Vanya, remember, has the operation to either subtract or add. So can Vanya do this part? That's he simply adds 1 to this and this becomes 6, which now falls in the category of numbers where n mod 3 is equal to 0. And yes, Vanya wins. Is that right? Now remember, if you take any number, I just took an example of 5. If you would have taken any number from this set, either 2, 5, 8, 11 or so on, then every such number over here plus 1 gives me a number that falls in the set of n mod 3 equals to 0. If you are at 2, just add 1, get a 3. If you are at 5, add a 1, you get a 6. If you are at 8, add a 1, you get a 9. If you are at 11, add a 1, you get a 12. So can I say that in just one move of adding plus 1, you can change your number having the property n mod 3 equals to 2 to be a number that's n mod 3 equals to 0, basically saying now it's divisible by 3 and Vanya will win? Yes, I can. That means if the number has a category of n mod 3 equals to 2, the answer is always yes. Because any number in that category, by simply adding 1, can be modified to the set of n mod 3 equals to 0. So third test case is done and dusted. Alright, now let's talk about the second case. Now similar to this, if you are standing in a set of numbers where you can say n mod 3 is equal to 1, and you want to change it to a case where you actually go to n mod 3 equal to 0. What happens now? Let's take an example. Let's say you are at the number, can I take a number like 4? Yeah, fine, 4 works. Now, if you want to go from 4 to a number which is mod 3 equal to 0 and you want Vanya to win, then can you say Vanya, by very smartly, how he increased plus 1 in all this category, can I do the same part and say I will decrease 1 and go in the category? How? Let's see. If you are at 4, can you decrease 1 and you will go to 3? If you are at 7, can you decrease 1 and you will go to 6? If you are at 10, can you decrease 1 and you will go to 9? And even if you are at 1, can you decrease 1 and you will go to the number 0, which again 0 mod 3 is equal to 0. Yes. So the same case happens again. Vanya has the power to either add or subtract. In the third test case, we understood, okay, in the third type, we took that, okay, if he adds 1, he'll go back to this n mod 3 equal to 0 case. But what if in this case, he simply says, oh no, I can just subtract 1. Will I still say, yes, I won? Yes, he will win, because by subtracting 1 from any number in this subsets, 1, 4, 7, 10, so on, these numbers, you will get a number that's a multiple of 3. So this also gives me yes. And now we can discuss the final case. That's the last case over here. I'll just take a new page. The last case. So over here, what we did was just completing this part. You will do a -1 and you receive a 3, which is obviously a multiple of 3. Now, what about the last case? The last case says, remember, the last case says that your number already is a multiple of 3. Very important. Already it's a number multiple of 3. Now, the players are playing smartly. They are playing optimally. So now, of course, Vanya wants that you come back to this location. As in, he wants that you are at a number which when modded by 3 gives you 0. But you are already at a number which by mod 3 gives you 0. Example, you are at the number 6 example. So you are obviously standing at a number that's a multiple of 3. Now Vanya has to play a turn. Either he has to increase or decrease. Let's just say he increases the number. Let's just say he does a +1 and you get the number 7. Now Vova plays. The turn of Vanya is gone and now Vova plays. Now remember, isn't Vova also trying to win? Yes, Vova is also trying to win. So can you say Vova will do a +1 over here? If Vova does a +1 over here, this becomes a 8, and then in the next turn I can do again a +1 for Vanya, and this becomes a 9 and Vanya wins. So will Vova do a +1? No, he wants optimal solution. He wants to win. If he wants to win, will he do a +1? No. What he'll ideally do to win is he'll try to counter whatever Vanya did. He'll say, okay, if Vanya did +1, I'll do a -1 and I'll take this number back to 6. That's Vova's turn. And now you're again back to 6. Now standing at 6, whatever Vanya did in the last turn, as in he did +1 and took it to 7, isn't that all gone? Is it then all futile? So when Vanya used his turn, then Vova used his turn, you came back to the initial number. That was 6 to begin with. And now Vanya, if takes the either route, if he says, okay, I'll do -1 and this goes to 5, then Vova can do the just opposite. He'll say, okay, I'll do a +1 and take this back to 6. So now in this case also aren't you back to the initial number? That means whatever Vanya does, Vova can counteract. Why would Vova want to counteract? Because Vova wants to win. So if Vova wants to win, I know that Vova being the optimal player will counteract anything that Vanya does. And you know this process is going to go on and on and on and on, and it's going to stop when you actually exhaust 10 turns. When you actually exhaust 10 turns. And after 10 turns, Vova will emerge victorious because he counteracted every move Vanya tried to do, and never Vanya was able to make a number after his turn. Remember, after his turn, not initially, after his turn, that the number turned out to be a divisible number, as the number divisible by 3. Alright, so after 10 turns, definitely this, you can say, infinite sort of a loop fails, stops rather, and Vova finally turns out to be victorious. So in this case, I can say that no, Vanya does not win. You can say Vova wins. Or simply like justifying this as with regards to the problem, you can say over here you would have reported second, meaning this Vova wins. And in these two cases, you would have preferred to report first, because this means Vanya wins. So essentially, what is the total idea now? What am I trying to simply do? Am I trying to simply say, take the input n, then check, is n already a number divisible by 3 or not? If it's already a number that's divisible by 3, simply say, I'm going to print second. And if the number is not initially divisible by 3, that is these two cases, as in it either gives you 1 by doing mod as in the remainder, or it gives you 2 as the remainder, just simply blind yes, print first. Alright, so this is the whole piece of problem. Now the explanation was actually the main part. Code is going to be very simple once you understand these cases, because I'm just working on a single number. So let's go to the code part. Alright, so this is going to be the code, literally 2-liner code. I take the input of t. Now I take the input of n. This is up till here taking the input, and then a very simple check. Do I think that n is already divisible by 3? If it is, I'll print second. That denotes Vova wins. Else, in any of the two other cases, I know Vanya wins. Alright, very simple code. Now what is the time complexity? We have achieved definitely a very good time complexity. That's constant, because all I'm doing is a simple mod check, nothing extra. And what about space? Again, I'm not taking any extra space in terms of data structure. It's just a single variable. So I can say space also turns out to be constant. Alright, so the idea was very clean. It's basically a very simple practice problem for you to understand how do players play optimally when they want to win. In this case, we observed that, okay, if Vanya won quickly only in one turn in both these two cases. But the other one case was actually a bit tedious to think. When Vanya tried to play optimally, Vova also tried to counteract that optimally, and hence at the very end, Vova turned out to be victorious. Alright, so this simulation is very important, definitely a very beginner friendly and a very good problem. Alright, so I hope you liked the video. Thank you for watching.